The next speaker is Isaac Freund. Isaac is studying computer science in Aachen, Germany. And while most of the courses in his university are about theory, he spends the bulk of his free time playing around with Linux and Wayland, which is more or less the same as what I did in university, if you replace Linux with Dota and Wayland with Counter-Strike. Anyway, the talk is writing a Wayland compositor in Zig, and so Isaac, the stream is yours.
All right, thank you, Christoph. Welcome to my talk on writing a Wayland compositor in Zig. And so I imagine many of you might be asking right now, what is Wayland? So I'm going to explain that to you before we continue. So Wayland is nothing more than a protocol for communication between a compositor and Wayland clients. And so this is meant to be a replacement for X11. If you do not already know, X11 is the display server used by Linux and other Unix-like systems today. It is what clients or applications on your computer use to talk to display something on the screen or get access to input events from your keyboard or mouse. This display server is responsible for managing all the output and input of your computer. So how is Wayland different from X11? Let's look at this nice diagram taken from the Wayland website. So in X, we have the X server, which is a single server. There's only one implementation of the X server, and everything else is an X client. And then the X server is the only thing that talks to the kernel, and using the kernel mode setting and evdev APIs, controls the output and input of your hardware. And then it talks to all the clients. The compositor is just another X client, your window manager or a compositor to like apply some fancy effects to your screen. However, on Wayland, all the display server and the compositor become one single program. And this simplifies things greatly because now there's not as much back and forth required to render one thing. Here, when an X client wants to draw something, it has to ask the X server, would you please draw this? And then the X server will have to talk to the compositor about where it's going to be drawn and how it's going to be drawn before it actually gets drawn by sending messages to the kernel. In Wayland, you're going to see there's a lot less back and forth. The pipeline is just Wayland client to compositor to kernel through the kernel mode setting API. So that makes things a lot simpler. However, it's obviously not very easy to write Wayland compositor if you have to do everything at once. You don't get to rely on the X server to do the heavy lifting for you. You've got to implement everything you want in your compositor directly. And so luckily there's a library called WLRoots that will help us out to do this. So what is WLRoots? It is a modular library for writing Wayland compositors. This means that you can use as much or as little of it as you want, and it will get out of your way when you want to take control. Also, as it describes itself in this README, it's 50,000 lines of code you were going to write anyways. So these are the code that would be shared between almost every Wayland implementation. And this is developed and used by the Sway project, which is, if you do not know, Sway is probably the largest Wayland compositor out there today, aside from GNOME and KDE. It's what I have been using until I decided to start work on my own project because I wasn't quite happy with some of the ways Sway does things and wanted to have my windows managed a little differently. And so Sway, libwayland, and WLRoots are all written in C. And so as I'm setting out to write my own Wayland compositor, the first thing I need to do is choose a language, right? And so the first criteria is that it needs to be able to talk to these C Wayland libraries, including WLRoots. Furthermore, it has to be fast because if your display server is slow, that's going to slow down everything else in your computer. That means garbage collection is a big no-no. We cannot have any performance compromises here because the more resources your display server takes up, the less is left over for everything you actually want to get done with your computer. Third, this language needs to be simple. A Wayland compositor is a non-trivial program. It is quite complex, even though the protocol itself is simpler than the X11 protocol. And so we need a language that's simple enough that the code is easy to understand and easy to maintain. And finally, we want the language to make it easy to write correct code. And that means, because nobody wants to use a display server that's got bugs. If your display server is crashing or has buggy behavior, that makes your computer unusable and nobody wants to use it. I wouldn't want to use it either. And so the first option, like the obvious choice, would be to just use C. This is what many of the successful compositors currently use. A couple are using C++, but C is what Sway, GNOME, and KDE are all using. So let's go through here. Obviously, C has good interoperation with C Wayland libraries, and it is fast. It's the standard most languages are measured against when you're comparing for speed. And C is relatively simple. There's a lot of legacy stuff, but it's not a language that would take a lifetime to understand all the intricacies of. And you're not as much debugging your knowledge of the language as your knowledge of your code. However, it's not easy to write correct code in C. C has null pointers. C has lots of implicit conversions and some nasty undefined behavior that will bite you. And so one might be tempted to say, what about Rust? I've heard about this memory safe language. It's supposed to solve all my problems with null pointers and whatnot. However, it is very easy to write correct code in Rust because the compiler will not let you compile incorrect code. And Rust is pretty fast. There's no garbage collection, but it cannot really talk to C Wayland libraries well. And so when you're setting out to write something in Rust, the first thing you need to do if you want to use a C library is either write bindings yourself or find someone else who's already written Rust bindings. Because writing Rust bindings to a C library is non-trivial if you want to take advantage of Rust's safety guarantees. And it's not too hard to write unsafe bindings in which you use unsafe Rust if you just use the C library APIs directly. But if you're using unsafe Rust, you might as well not be using Rust because then you lose out on the safety guarantees it makes. And so are there any safe WL roots bindings out there? Well, this project was attempted by Waycooler, which is another compositor project who attempted to write a Wayland compositor in Rust. However, they gave up on the safe WL roots bindings after over 1,000 commits and over a year of work just on writing the bindings to use Rust with WL roots. And this is nothing against them. They are very capable programmers and know far more about Rust and WL roots than I do, I'm sure. But it is not a non-trivial thing to wrap this API in a safe way because pointer lifetimes in Wayland conflict very strongly with Rust memory management. And Rust memory model wants to have everything known at compile time, so it can be statically checked by the compiler. But in Wayland and WL roots, these pointers can become invalidated at runtime. For example, if you suddenly unplug your monitor from your computer, then WL roots, that means that this pointer will receive an event that says your output has disappeared, and this pointer will become invalid. And it's very hard to wrap that kind of API in Rust in a safe way that avoids runtime checks. And so if you want to read more about their story and the details of trying to wrap this API in Rust, you can read more about it here. And so this is not to say that it's absolutely impossible. However, I think it's become clear that wrapping this API in safe Rust is not going to be simple. And so using Rust also does not check this last checkbox of simplicity. And so is there a better alternative? And this is when I came across Zig. I first read about it on Lobsters or Hacker News or something. And I started reading through their website and saw an example of importing libsound.io and just using it instantly from importing C code into your Zig code. And so I thought, why not try this out? So does it have good interop with the C Wayland libraries? Let's go look for an example here. So this is something that gave Rust a good bit of trouble. So this is very C-ish code that's in Wayland. So here we have a WL listener. In Wayland, the whole idea of Wayland is very callback based, meaning that the server sends events to the clients and the clients make requests to the server. And so you register a callback with the library to listen for any requests made by clients, and you do that using this WL listener struct. And so this is made up of a notify function. Is a type def for the type of this notify function. We'll get into that in just a second, and a link in a WL list. A WL list is an intrusive doubly linked list, which just has two members, a link to the previous and a link to the next. And so this tells us that this struct cannot move in memory, otherwise we would break this pointers in the list and invoke some nice C undefined behavior. And so this struct must be pinned in memory, and we have to deal with this intrusive linked list. And so this is an example usage in C. We have our server struct that will hold our listener and a bunch of other fields probably, and we will register a callback. defined this to call back the function pointer type we have here, and it will take a listener and a void pointer to some data that comes along with the callback. And so we just all we get is the pointer to the listener this callback is registered on. So how do we get access to our server struct and the rest of our stuff? So we have this pattern. This is a nice C macro, WL container of. So what is this thing doing? So we pass it this pointer to the listener. We pass it a initialized pointer to a server, and we pass it, what is this? This is the field name of the member of our struct that this listener is. This is a pointer to this member of a struct somewhere in memory, and we pass it. This macro now gets the type of the struct, and we get this pointer to this memory, and so this is able to then conjure a pointer to this server struct that owns this listener as a field. And so this is a little bit complicated, a little bit hard to translate to non-C languages. And so this is the kind of the bread and butter of Wayland APIs, though. Everything is callback based, and so this is a pattern that happens all the time in Wayland. And we're also just casting this nice void pointer into the data that the libwayland has told us we will get with this callback. And so let's briefly look at how this could look in. This is the definition of the C macro. Yeah, so this is from libwayland. You can see it's just doing pointer math. It's taking the offset of this member of our the offset between our listener member and the start of our struct, and doing some pointer math to get a pointer to the start of the struct and therefore the rest of the struct. And so is this possible to do in Rust? This is from the Wayland sys Rust crate, part of the Wayland RS project. And so they have a definition of the offset of macro here and a container of to implement the same thing. However, we can see from this to-do comment, this is really not undefined behavior. It turns out this is currently undefined behavior in Rust, and there's no sound way to implement this. There is an open RFC that will provide a way to do this in a well-defined way. However, that has not seen a whole lot of progress, I don't think. I'm not totally up to date on the status of that, but eventually Rust will have a safe way to do this. But currently this is undefined behavior, though it does work, and this library does work. There's also a pure Rust implementation that avoids this issue. But if you want to use bindings to libwayland, which you would have to do to use WL roots, there's not a sound way to do this in Rust. And so what about Zig? How does Zig solve this problem? We have this wonderful compiler built in. Fengbi talked a lot about compiler built-ins in his talk. But Zig exposes this field parent pointer compiler built-in, which takes a type. In Zig, we can pass types as first-class values at compile time. And it takes a field name. This is the name of the field in our struct for which we provide a pointer. So we pass a pointer to a field, the name of that field, and the type. You can already tell we've got a lot more type safety here than the C macro equivalent. And it's also, we don't need a macro. We already have a compiler built in, and it returns as a pointer to the parent type. So let's now take look at an example of using this whole API in Zig. The first thing we need to do is import the part of Wayland that we want to use. So we'll use this C import compiler built in and assign this whole import to a variable C, which we'll use as our namespace. And we will import the Wayland server core. This is from libwayland, and then we'll import something from WL roots just to try this out. We'll import the XCG shell, which is the main desktop shell that applications use for like normal Windows on your desktop. Is how you would think of that. So first we import our source. You notice we don't actually need any bindings. This is just, we type in the name of the header, and it magically imports into Zig code, which I think is really cool. And so, we are just going to define our server struct like we did in C. We have my listener as our field. The type is the WL listener and the C namespace, and we call it a struct server. And then we have a callback here. So let's go into what's going on here. This is a function. We have our first parameter is a listener. What's this question mark here? This is an optional pointer. Zig does not have null pointers, which is really great. And since we're using an external C library, the compiler does not know if this pointer is null or not. So it forces you to use an optional here. And this is an optional pointer to the WL listener, like before. And then we get data, which is a C void, optional pointer to a C void. We say this got the call convention of C calling convention so that we can then pass a pointer to this function to libwayland in order to receive our calls. It's a callback, and it returns nothing, it returns void. So let's look at how we use field parent pointer here. We just pass the type of our struct, we pass the name of our field, and a pointer to our listener. And we have to dereference the optional here, but we know this is safe because the lib Wayland tells us that it's not going to pass us in the pointer here. So unless we do something wrong, this will be a good point, a safe pointer. So then we can get our my server pointer. This is now a pointer to our server. And let's look at this next part here. This is also very interesting because remember, if we go back to that example in C, we can see there's no scary stuff here. It's just data, which is a void pointer, becomes a WLR XEG pop-up, which is honestly a little scary because this could be a pointer to literally anything. It's a void pointer in C. And so let's look at how Zig solves this. So here we're doing a pointer cast that's already much more explicit than the C version. And we're casting, this pointer cast takes two arguments. It takes first the type of what you want to cast a pointer to, and then the pointer you want to cast. But we're doing something else here in the second argument. We want to cast this data pointer, but we can't just pass it straight to pointer cast because the compiler doesn't know what the alignment of data is. And Zig cares about alignment. It will not compile if you just pass data directly to pointer cast. You have to first align cast this data pointer and to the alignment of this struct in C. And so this is, in my opinion, much better than the C version. Not because it's easier to write, but because it's much more explicit about what's happening and what could go wrong here if the library passes you the wrong stuff or if you screw something up. And so it's not, you could totally overlook the other thing. It was just if we did not have these built-ins here and all this, it might seem like noise, but if we just say pop-up equals data, then you're just casting, and you don't know what this is, and you're passing it to your pop-up. So this is very explicit, and it gets the job done without getting in your way. So I really like that aspect of Zig. It's very explicit and readable. So we've checked off one box in our language checklist. Good interoperation with C Wayland libraries. What about the other ones? Fast. Zig is fast. Zig has a goal of beating C at speed, and the plan to do this is through well-defined undefined behavior. C, for example, integer overflow in C is undefined for signed types, and for unsigned types it is actually defined in C. However, Zig makes it undefined behavior for both of them and provides other overflowing operators which it is defined. So this is just one example of how Zig has made some choices early on in its development. You set it up to be faster than C. And so Zig is also a simple language. This is my first project I've ever attempted in Zig. I literally read about the language and thought it would be worth trying. And so I just started messing around with it, just poking around with it. And I ended up just never stopping. And I have been working on this project for about 2 months now and have gotten pretty far. This is my first Zig project. I'm not sure I could have done this in other languages like Rust or C++, for example, because they are much more complex. There's a lot more to learn in those languages. In Zig, I already had a fair bit of experience with C, and so that I found translated very well to Zig, and I was able to pick up most of the subtleties of Zig in my first week of programming language. I'm not a master yet by any means, of course, but my knowledge of Zig is enough that I have been able to write a non-trivial program in Zig as my first project ever. So I think that speaks a lot to the ease of learning of Zig and the simplicity of that. And is it easy to write correct code? So this is where we need to look into what Zig brings to the table that you don't have in C. And so let's talk about a little bit about the benefits of Zig. So we've seen that it's about as simple as C. You can do the same stuff. So why do you want to use Zig? The biggest thing for me is maybe not the most exciting thing, but the optional type it's a small language feature, but it's so critical. Null pointers are the cause of so many bugs, and having the nullability of pointers built into your type system can just make everything much easier to write. And so let's take a look at how this works in Zig. For example, we can implement a linked list using optional pointers. And this is very relevant to Wayland as well, because as we saw earlier, the WL listener type, it cannot move in memory or else we will break pointers that libwayland is relying on. And so all of our data must be static in memory. It cannot move around. So that means we need to use data structures that preserve pointer stability. And so we'll use linked lists primarily. So here we have a list which contains another struct type. We have a node, which contains an optional pointer to the next node and the previous node, as well as some data. Here we store a view, which would be just like a window on your desktop. And also in the list struct, we store an optional pointer to the first node. And so to iterate over the nodes, we'll notice that we actually have language level constructs in Zig to work with optional pointers, which is much nicer than null checks everywhere we see and not knowing when you need to check for when you don't, because any pointer could be null really. And so here we set the current to the first pointer here is now an optional pointer to a node. And we say while current, this construct here, while current, and then we have got these line braces. I'm not really sure what to call these, honestly. And so if current is null, we will end the loop. If current is non-null, then we will take the inner value of current. So node is going to just be a non-optional pointer to a node, and a pointer that we know must be valid. And so we can then do something with node inside of this loop. And then for the next iteration, we set current to the next node, and then check again if current is equal to null or not in this nice language level construct that makes working with optional pointers much nicer. And so that's one major feature of Zig. I mean, I cannot sure I can state enough how much just having the optional type changes your code and makes everything so much easier to read. So the next really cool feature of Zig, in my opinion, is nice error handling. C doesn't really have any error handling built into the language. It's all based on returning sentinel values or returning false. It doesn't have rules built into the language anyways, so returning something that would evaluate to false. And so Zig has made some big strides here. So we can define an error set, and this is just a set of possible errors that could occur for some language. So we're going to talk about the compositor commands. Use these as an example here. So we're parsing a command that could be run in our compositor. We could receive not a command, something that's not a command, or an unknown command, or not enough arguments were given, or too many arguments, or we failed to allocate and ran out of memory. So let's look at some usage. I'm sorry, there's a lot of code here, but I think it will demonstrate kind of the control flow of Zig with regard to errors. So here we receive an args list, which is just a slice of slices. So you can think of this as a pointer to a two-dimensional array of sorts. And so if we have no arguments in our argument list, we can just return error.no command. And notice our return type. Here we've got a union of a command. We either return a valid command or return an error. And so here we can just return an error and it will automatically convert to this return type. And so first thing we would do here is look at our first argument and see if we can find this thing in our list of definitions of valid commands. If we just compare some memory and see if this argument is equal to one of the definitions, then we'll return the definition. We'll set this variable to the definition, otherwise we will return the unknown command error. And then finally, we will construct our command using the definition, which is now contains a function pointer that we can use to run the command, as well as trying to parse the rest of the arguments into the arg we want to pass the command. So here we have this try keyword. So that means that this arg.parse function can also return an error, which would be then one of these errors, which would also automatically get returned here. And if this doesn't return an error, then it will assign the result of this, which would be an arg to this value, and return the command. So this control flow really gets out of your way. It allows you to just call functions with the try keyword to automatically return an error if they fail. And then in this way, you can pass your errors up the call stack with minimal effort. And you can also, and it's just easier to work with a set of errors where you know all the errors that can possibly occur. And it's not just sentinel values where it's easy to mess up. For the sentinel values, it's not encoded in the return type that there can be a sentinel. And so you need to read the documentation to see that, oh, I need to check for -1 here. If it's -1, that's an error. Instead, here you see that it's an error, and also it becomes then a compile error to not handle the error. For example, if we left this try out here, or compile, because this returns not an arg, but an arg union with the error that can be returned by this function. And so that would not coerce into this type. And so this makes writing correct code in Zig much easier than it is in C. And so the other major feature of Zig, which is an anti-feature maybe you could say, is not having macros. And so we already saw one nice macro that's used in let's look at another nice macro we have. This is to work with the intrusive linked lists we saw earlier. And there's this macro, WO list for each. So this code probably looks kind of weird. It's like, this looks like a function call, but then we've got opening curly brace after it, and we're like iterating over a loop. And so it turns out inserting a for loop here, and it's using these parameters to determine what the for loop is going to look like, and just to save you some code writing. So you can see the macro definition here. It's creating a for loop using, again, this WL container of macro, and this quickly becomes kind of unreadable. So when you see this kind of code for the first time, reading Wayland code, it can be very confusing, and it's not obvious at all what's going on here. I mean, you can see that it's iterating on something, but what are these parameters? And you don't really get the type safety you can with Zig. And so I consider this an anti-feature, which is having to rely on macros to do simple stuff like iterate over a linked list. And so in Zig, we have this feature called comp time, which is really nice. It allows us to do all sorts of stuff. So let's go back to our list example earlier. Earlier, we just had one parameter could only have views as its type. Here, we'll make a generic list. And how we do this in Zig is we create a function that returns a type and takes a type as a parameter. Zig doesn't really have generics. It just has the ability to pass types around as first class values that compile. And with that, you can easily make generics in that you just have a function that takes a type as a value. Then given that type value, we create our own struct. So this is similar to the list definition we had earlier. Sorry. And we create a node, again, with these optional pointers in there, except data is now t, which is this type we were passed here. And so then we return this type from our function, and that's all it is. Then we can just call this function whenever we want to get the generic type based on what we passed to this function. And so this means we don't need to do this to have nice iteration over the list, and we don't need to use an intrusive list either. So this is a really nice way to keep the language simple, while at the same time having nice features like generics and not needing to rely on macros to get the job done. And so I think that's a pretty solid argument of why Zig is worth considering if you have a project that's low enough level that you need to really interface with complex C libraries and work well with C, while at the same time, yeah, you need to have a nice language you can work with. I mean, I'd much rather write Zig code than C code because of these nice features we have in a much more language. So if you're interested in my project and my work in this compositor, feel free to check out the GitHub or talk to me on Discord or IRC. And thank you for listening.
Okay, thank you very much, Isaac. Let's move to the Q&A now. So just a reminder for everybody, same as before, if you have a question for Isaac, you can use Twitch chat, the Zig IRC channel on Freenode, or the Zig Programming Language Discord server. Just make sure to tag me on it. And let's move to the Q&A view then. So Isaac, let me first of all center you a little bit better because you have a different ratio than the others. Okay. So let me start by the usual question. So you mentioned already that you discovered Zig then on Hacker News, right, on something, and you immediately went to work into to this project, right?
Yeah, not immediately. I had read about Zig at some point, and so when I was thinking about writing my own compositor, Zig was kind of in the back of my mind as a possibility. I had never really done anything with the language besides read the documentation on their website and just like see a couple examples. But I guess it stuck with me that you could just import C libraries and use them directly.
Okay, I see. Is there any other project that have you been working on other than Reader?
In Zig, not yet, though I will definitely be writing some companion apps for River, I guess. I still need to write a status bar, which I consider out of scope for the compositor itself. And so that's likely going to be in Zig. And also have a lock screen for Wayland that's currently written in Rust. But I've been considering rewriting it in Zig because I think it could be made a lot simpler than it is currently. So I'll definitely be using Zig for future projects though, as I just really like the language. It's a joy to work with, to be honest.
Okay, cool. I think there's a question from K Proti. Is River's goal to be a replacement for libwayland?
No, River does not. Or wait, for River is a compositor. So this is like Sway or GNOME or KDE or any other window manager. And so what this does, I mean, I can demo it if you want.
Okay, give me a second. I'll switch back to the other view. Okay, we can now see. Keep in mind that your font size is very small.
Yeah, I'm sorry about that. But now we are in River, so we can just like spawn some terminals and we can run htop. It doesn't really matter what is displayed on the font, but we can see that there already are some features working on Compositor. We've got kind of a layout like DWM where it's dynamic, and we can open an editor here and I don't know, edit something. And so if we want to like focus on our view, pop it up to our main view, and we also have tags here. So we could send this view to the second tag, and we could view the second tag and go back to the viewing the first tag. So this is River. It's a compositor. It's a window manager as well. And I really enjoyed writing it and enjoy using it as well. So hopefully that explains a little bit more about what River is. Like I said, and do a great job of explaining the project itself, about the language I was using.
Okay, I see a lot of comments. People on Twitter are saying that it's pretty sleek. Yeah, it definitely looks awesome. Okay, so you mentioned that so you started using Zig around this time. You don't have any major projects. You're planning to write a few companion apps. Any other thing that you are interested in writing that you might do in the future?
Yeah, so let me think about that for a second.
Sure.
And so one thing, so this I've mentioned briefly that I had written a lock screen in Rust already. And so one cool thing you could do with Wayland is that the lock screen could also be a Wayland compositor, or a very limited one. And so you could theoretically run any Wayland app as to give you the graphics for your lock screen. For example, you could run like MPV, like a video player, to then play a video as your lock screen, but still running that inside the lock screen compositor, so that your computer would be locked, but it would be displaying a video. So I think that would be a pretty cool thing to do. But that gets rather complicated, so I'd rather do that in Zig than Rust, to be honest.
I see. That's awesome. So one thing that I'm thinking, maybe this is just I don't know. You tell me if it's something that doesn't make sense. But is there any connection to what, at the end of the day, also OBS is doing? For example, when composing a scene that is broadcasted on stream.
Not sure I understand the question. But,
well, have you ever used OBS?
No, I've never used OBS.
Okay, well, so for example, when I use OBS, I can do more or less what you were describing earlier. Of course, it's a different layer of the stack, so it's not a one-to-one mapping, let's say. But in OBS, you can set up a scene where you have a bunch of sources. For example, right now I'm showing a overlay. There's your webcam in the corner. Then there's another source in the middle of the screen that is showing your desktop. And
right. Yeah, so
yeah, please continue.
Yeah, so it's a similar idea. Definitely, it sounds like they're both doing compositing, which is just like taking a bunch of parts together and putting them together into one image or one buffer to be displayed on an output. However, Wayland works quite differently than OBS, I believe, in that it's not a network transparent protocol, meaning that you can't. The network it has to pass file buffers around in order to achieve this shared memory model. In Wayland, every application renders directly to a file to a buffer, which is then used directly by the compositor without copying stuff around. This is what allows Wayland to be potentially much more efficient than X11 with its rendering, and be much more energy efficient as well, saving your battery life and whatnot. However, this you can't really pass a file descriptor over the network and expect things to work out.
I see. But okay, another question. How does so I know I understand that the two things are not exactly compatible because I see that you have this tiling set up where everything is well organized and hierarchical, but what happened to? I remember when I was using Linux a while ago before I got like lazy and moved to macOS and yeah, pretty much stayed there. But what happened with Compits, Beryl, and all the 3D crazy effects and wobbly windows?
Oh yes, yes. So you definitely want to check out a compositor called Wayfire. That's another Wayland compositor that's using WL roots, and they have all these wobbly windows and fun stuff. They also have like fire windows, and like so the window just like drops down like with a burning animation. It's pretty cool. So you can definitely do that stuff with Wayland as well. But you have to implement it in the compositor, not in like a another client like you would do in X. That's Wayfire.
Oh, okay, I see. Okay, so we have a couple of we have a question. So, do you plan to use River as your main driver eventually?
Yes, yes, that is my top priority right now, is to get to the point where I can use it for all my stuff. There's only a few things blocking me right now. X Wayland already works pretty well, and I've already got most of the protocols implemented that I need. The only things blocking me are like easy configuration and a status bar. And so I'm working on a custom Wayland protocol that will allow the compositor to talk to the status bar. And so once that's done, I can either patch some existing status bar or write my own and have a nice status bar at the bottom, which will keep me. It's just much nicer to use a compositor with the status bar, in my opinion. And then the other thing is having good configuration. I already have a River CTL program. I can demo this also real quick. Zig bin River CTL. Zoom. Let's just zoom to the next view. And so instead of using the keybind there, I've just like run for another separate binary, which then talks to my compositor through a custom Wayland protocol, and then tells the compositor to do the zoom command, which is just zooming to the next window, or if I have a window that's not the master window focusing that window. And so that already works, but I don't yet have the capability to bind keys using this River CTL program, so I need to implement that. And once that's implemented, all the configuration can be done just through a shell script calling River CTL and binding all your key bindings and performing all these commands just through a shell script. Right now, most of the stuff is still hard-coded. So once I get that stuff de-hard-coded and get my bar worked out, I'll be using this full time.
We have another question from Johnny Marler. Does Wayland support something like X11 forwarding?
X11 forwarding. So it's not the same thing. Wayland. So right now I'm streaming this. I'm using Sway right now. This is streaming to you over WebRTC using the WLR screen copy protocol and WebRTC and Pipewire and a couple other technologies. So this is not the same thing as exporting. It works quite differently. It's just streaming the whole entire buffer, but in a nice, efficient, compressed way. And X forwarding, as I explained earlier, can't really be done with Wayland. At least no one's figured it out yet because of this problem of passing file descriptors around, which can't be done over the network, or at least no one's figured out a good way to do it yet. Hopefully that answers your question.
How easy is it to write Wayland clients in Zig? Asks Jones.
Well, it's about the same as writing them in C. I haven't actually written a Wayland client. Actually, yeah, the River CTL is a Wayland client, so I can show you the source code for this real quick, actually. I can even do this inside River CTL. So how this works is we just import Wayland client.h. This is our C import thing, and we import the header from my custom protocol, and then we connect to the display. We get the registry, which shows all the Wayland globals we have. Writing this might require some uncertain understanding of Wayland, but you'll probably be learning more about Wayland itself than writing a Wayland client in Zig. But you can see this client is not very long. This is only a little bit of code. Obviously, it would take a lot more code to write a graphical client, but this is a very simple demonstration of how a Wayland client can be set up and function. So if you want to check out the full source code, it's on GitHub, of course. I linked that earlier. I can link it again, I guess, at some point. But yeah,
Yeah, I
would
think
definitely recommend it.
yeah, I think other people also linked it in chat. So we have another question. So it's a bit long. Let me read it all for you. And somebody else is also posting a link again. That's awesome. Thank you. So the question is, Isaac, you mentioned that there were some things you didn't really like about Sway and how it manages Windows. I don't have much experience with Linux Windows programming. Can you explain how the compositing code can affect writing a desktop app? And what are the things River does differently than Sway?
So my issues with Sway are mostly is manual Windows management. So let's go back to Sway real quick. Actually, I can demonstrate this. So now we're back in Sway on my normal desktop. So you can see that when I'm opening new terminals, they always appear next to each other, unless I explicitly say you should appear down below. And it's all manual here, and I can't just like say make this terminal bigger. I can make it full screen, but I can't just make it to the left. And so you can see this works very differently than how things work in River, and that when we make new terminals, they're automatically tiled in this layout, and we can automatically snap other terminals to the main view. So that's the main difference between River and Sway. River is doing what's known as dynamic window management, which was popularized by DWM, made by Suckless software, which is called the dynamic window manager. But there is not or at least to my knowledge, no one's written a dynamic window manager for Wayland yet. So that's what I set out to do.
Okay. I think that's awesome. Thank you very much. Thank you for preparing the presentation, also for answering the questions. That's an interesting project, and I think the demo really sells the idea behind the project. So thank you very much. And I think it's time for us to move to the final part of the session today. Thank you again, Isaac.
Right.
You can now go.
Thank you.
Bye-bye.